Welcome back, guys. Today we will be verifying that a solution is for the differential equation that we have. Let's get into it. Today we'll be doing a differential equation proof. Here we have if x is equal to e to the negative 3t sine 3t, show that d square x over dt square, which is the second derivative, plus 6 times dx over dt, which is the first derivative, plus 8x is equal to 0. So this, I am going to substitute the second derivative, the first derivative, and x. I need to substitute and then simplify to get 0. So x is equal to e to the minus 3t sine 3t. Now this I need to differentiate because I need to find what is dx over dt, differentiating x with respect to time. And in order to differentiate this, I have to use product rule because it is side by side. So that's why I'm using product rule. So what I'm doing, I'm differentiating e to the minus 3t, it becomes negative 3 e to the minus 3t. Then I rewrite the sine 3t plus, then I hold e to the minus 3t and differentiate sine 3t. So I'm going to have e to the minus 3t when we differentiate sine 3t, it becomes 3 cos 3t. So that's the derivative. So 3 cos 3t. So this is differential of x with respect to time. Now I need to do the second derivative. So I'm going to differentiate a second time. So I'm finding d square x over dt squared. That's the next thing I'm finding. So I have to apply product rule twice. So here I'm going to differentiate minus 3 e to the negative 3t. You differentiate the minus 3t, we get negative 3, then multiply by negative 3 in front, we get positive 9 e to the minus 3t. Now I'm gonna leave sine 3t alone. Remember, I'm doing product rule. So I hold one, differentiate the other. So now I'm gonna have my plus. Then I am gonna differentiate sine 3t and leave the exponential alone. So let me just write plus. Not gonna simplify anything else as yet. So I'm gonna have minus 3 e to the negative 3t. Now remember, this I haven't differentiated, I'm just rewriting it. That's how the product rule goes. And I'm going to differentiate now the sine 3t. So the derivative of sine 3t is 3 cos 3t. Now, the next side that we have, which is e to the minus 3t times 3 cos 3t, I have to differentiate. So differentiating e to the minus 3t, I will have negative 3 e to the minus 3t. If you're forgetting the rules how to differentiate exponential and cos, remember I have videos on these, so you can review my videos. Now, I differentiate the exponential and I leave 3 cos 3t as is. So I'm just going to rewrite that part. So we have 3 cos 3t. Now we're going to leave the exponential as is and differentiate 3 cos 3t. So writing e to the minus 3t. Then differentiating 3 cos 3t, 3 3s 9, and the cos becomes a minus sign. So this is minus 9 sine 3t. Now we can go ahead and multiply and simplify this. So the 9, I'm going to just write it in the same order, because if you look, we also have something that we can rearrange looking similar to what we have here. So rewriting it in the order where I have minus 9 first and e to the minus 3t sine 3t. It's similar to the first term that we have. So we have 9 e to the minus 3t sine 3t. Then I'm gonna 3 3s 9, but because of the sign, it changed to minus 9. And then I have e to the minus 3t, then cos 3t. So if you realize I'm arranging them where I have the number, then the exponential, then the trig function. Same thing here, negative 3 times positive 3, that's negative 9. So I have negative 9 e to the minus 3t cos 3t. Now the last part, I have e to the minus 3t minus 9 sine 3t. I need to change the order of this, so it becomes negative 9 e to the minus 3t sine 3t. Now looking at this, these two cancel, so I'll cancel these two. Well, I can add the center, they're looking the same with the same sign. So the second derivative, which is a derivative of x with respect to t, and remember it's a second derivative, it's going to be, you add the minus 9 and the minus 9, that gives you minus 18, and then you rewrite the exponential and the trig functions. So minus 18 e to the minus 3t cos 3t. So we have the second derivative, we have the first derivative, and we have x, so we can substitute into the equation to see if we get 0. Now we are going to substitute all the information that we have here. So the second derivative will be substituted, the first derivative, and x. So let me first write the equation. Now where I have the second derivative, I'm going to replace it with this minus 18 e to the negative 3t cos 3t. Then I'm going to substitute for the first derivative, dx over dt, with all of what I've found above in the first part, where I found dx dt to be minus 3 e to the negative 3t sine 3t plus e to the minus 3t times 3 cos 3t. So the next part is to replace x, which is in the question, which is e to the minus 3t sine 3t. So we just have 18 multiplied by e to the negative 3t sine 3t. And we are trying to show that this will give us 0. So where I have the square brackets, I'm going to distribute the sign. So let me rewrite the minus 18 e to the minus 3t cos 3t. And then I am going to multiply 6 by everything that's in the square bracket. Now multiply 6 times negative 3, that gives you minus 18. Then I rewrite the e to the minus 3t sine 3t. Now multiply 6 times this 3, I'm going to get positive 18. So I have positive 18. Then I rewrite e to the minus 3t cos 3t. Then I rewrite 18 e to the minus 3t sine 3t. And after writing this, I'm going to look at what cancels, because I need to see 0. So here we have this negative 18e minus 3t cos 3t. Cancel with the positive of it. Same thing with the negative of e3t sine 3t times 18, cancel with the positive of it. So this is 0, and we have now proven that the differential equation is 0. Thanks for watching, guys. Don't forget to like and subscribe to my channel. Have a great day.